Glaciers, glacial movement, cryosphere and glacial landforms. Mammoth hunters. Well, 9,000 years ago, the last mammoths wandered the tundra, shaggy relics of ice of age. When humans arrived, the end came swiftly. Spears and hunger finished what climate had begun. Beneath today's thawing permafrost, their bodies reemerge, mute witnesses from the frozen archives of our planet's deep history. Cryosphere, what is that? Earth's frozen skin, and it's melting. As ice reflects sunlight, its loss darkens the planet, speeding the very warming that destroys it. From Siberia to Alaska, mammoth tusks shine in the thawing soil as if the ice age itself were giving up its ghosts. Glacial sediments. What is a glacier? Well, glacier begins by snow, right? Layer upon layer, compacted under its own weight. The flakes, they all get smushed, I guess. The more they're crushed, the bluer the color is. So that's why if you see sometimes a glacier will have different colors depending on the layer. Glaciers and how they move. Well, Minnesota, a lot of our landscape is made by glaciers after they melted. But you can see a lot of things going on here, right? And a lot of things that are left. Right? Well, we'll talk about these different formations here. Where's a good picture? Now I was talking about this actually in the other lecture, glacial erratic, right? This was left behind when the glaciers melted, because the glaciers, as they expand, they push stuff all over the place. Oh, here's a good example of the different layers, right? Compacted through time. Basically, if you get a fresh snowfall, it has a lot of air in it, right? And that's why when you step on it, it smushes down. Well, imagine eons of time and that smushing down, really compacting things. That's the further down the glacier you get, the more tough. And it's tough to think of that water. It can be as strong as steel, and so picture that carving through landscapes. Ice flows, well, we talk about it being kind of a plastic movement, right? Slow, steady. When you say something is moving at a glacial pace, doesn't mean it's not moving, but just very slow, right? Basically, usually, each year's snow adds a bit of a layer and kind of like smushes it along. Most glaciers, they creep centimeters a day, right? Sometimes they do surge. Sometimes that could happen. It kind of depends. Sometimes they could race, but, not usually. And you can see the abrasion here creates these lines, right? Similar to this one, where you can see it's actually grinding off the mountain. Glacier flow rates. As you can imagine, the part of the glacier that is closer to the underlying rock goes the slowest, and the furthest away goes the quickest, right? And you can see this type of thing on time-lapse photography, which I don't have, but I got these images showing you basically snow, right? You get snow very often in a mountain, and that kind of crushes the snow and it pushes it outward. And if you have a lot more snow than melt every year, then you have a growing glacier. If you have, more melt than you have snow, then you have a shrinking glacier. Glaciers and global warming. Most of the glaciers are shrinking. Now, there are actually some, only a few percent, that are growing. That is because there are some places in the world where the air is a bit warmer than it used to be, and so it could hold more moisture. And so just randomly, some glaciers are getting a little bit more snow than they used to because of warming of all the crazy things. But most are shrinking. Most are shrinking. Excuse me. Of course, Antarctica, covered in ice. One of the few places that we know of that is, well, and it's not 100% covered actually. There are areas called dry areas where it's just so dry there isn't any moisture, right? Greenland and Antarctica, both ice sheets, right? Alpine glaciers, we've seen some of those already, right, with the stripes. There's lots of different types of these glaciers. Like I said, Minnesota, history of glacial formations. You can see a map like this that shows, terminal moraines. That's the area that when a glacier grows, it smushes everything out to that area, and then when it recedes, it just leaves that stuff, right, that is smushed down. Right, we've had actually a lot of ice ages. There was a past ice age that they've referred to as Snowball Earth, where the entire Earth was covered in glaciers. This is, of course, far before there were humans, but you could imagine how bad that would be for the ecosystems at the time. There's a lot of formations that have been ground up because of glaciers moving across them. This is a more detailed map of the different end moraines and things that were left by the glaciers. As you can see, well, the moraines go and push up material, and then they come back, and usually there's a back and forth, and so there's actually lots of different layers that are stuff that's kind of pushed up. This is in general also why we have our Great Lakes carved out by the glaciers. And then when they receded, they were still there. Although there were glacial lakes that were more than this. There was one above Minnesota. Well, it wouldn't be on this map. It's off that map. Greenland, another ice sheet. You can see there are places that don't have ice. That's true. Greenland ice sheet. That ice is so thick it actually is squishing down Greenland itself. And so the area under the ice is actually below sea level, but the ice is just stacked up above it. Alpine glaciers of the world. An example of what they look like overhead. Calving, that's the ice breaking away in a glacier that is on the ocean, and that's a natural process, although it speeds up with global warming. Calving processes just happen a long time. That's what creates icebergs that are floating around that can be danger to Titanics. Ice shelf. We have this in Antarctica where the ice has come out and it's over the ocean, and the warming ocean has made these great big huge icebergs break off, but there's less boats down there, so it makes the news quite a bit less. But you could see that layer, right, and how blue. And of course, we've mapped all these different glaciers and the rate that they're melting and how far back they are. We've got plenty of photos, but we've had satellites for a long time, and so we've been able to map a lot of these. Obviously, this one was mapped before there were satellites, but a lot of glaciers in areas that are less accessible than this one. Ice shelf, again, the huge ones break off, but mostly in Antarctica. Glacial erosion, like I said, these glaciers can come through and the ice can be as hard as steel, and so they could carve out Finger Lakes. If you've ever been to some place that has something called Finger Lakes, they're usually just these little long, and they're carved out by glaciers moving around. Abrasions, if you go hike over at Taylor's Falls, for example, and you could see a lot of glacial markings that have happened. This is Alaska, which I've gone to a few times to kind of study the glaciers and kind of see what's going on. This is what one of those braided streams looks like from the ground. And I flew over, got a picture of the glacier that was there. You can see a lot of glacial melt, right? A lot of glacial melt happening. Again, this is all in Alaska. And you could also see all the material that was carved off the mountains there, just kind of being deposited as the glaciers recede. It just kind of leaves that stuff. This is still Alaska, but this is an area carved out by a glacier. You could usually tell because they don't have the V shape of if it's been carved out by a river. They have more of a U shape. These markings on the rocks, you could go to national parks in Idaho, actually. In this example, it's Alberta, but you could see these in Idaho where the rocks still have the lines, because when the glaciers come through and they're dragging rocks, it makes marks. And you could even see the lines and tell which way the ice was flowing. Glacial erratic, again, big rocks left behind by glaciers. Glacial steams, in those ice caps, there are areas where it melts, especially if something has happened to darken the top of a glacier. Pollution from a long ways away is darkening a lot of different icy areas. And what that means is that changes the albedo, it warms up more, and so then you have a whole bunch of melting, right? Lots of different types of erosional patterns. I'm not going to go through every single one. But, this is where a number of glaciers came together, right? And they were grinding up a mountain. And then when they receded, when they melted off, they left the area that was grinded up as this little point. You can understand why it'd be called a horn. Oh yeah, if you want to see fjords, you can see them in Alaska, but there's a lot more in Scandinavia, which is why they included this picture from Scandinavia. Again, the stuff that's left over from glaciers, the stuff that's at the end of glaciers, the stuff that glaciers have pushed from other areas. Lots of different types of moraines. Another example of kind of what's left after the glacier starts to melt, a lot of that stuff that it pushed up, right? Kind of like piles of debris, and you could tell where the glacier used to be. Washington State. The ground is pretty uneven with all that stuff that's kind of left behind. As you can see, the areas next to it are farmed, but on it, not so much. And it's not that the soil isn't good, it's just like so lumpy. You'd have to do a lot of work to make it so that you could just do regular farming. Some things left, again, when the glaciers recede that are often made underneath a glacier. If there's melt, you could have a glacier deposit stuff underneath itself in these different types of piles of debris, basically, is I guess what I would call them. And you could still farm them, as you can see. You just got to be a bit more inventive. Kettle lakes. If you've ever been to a lake and it gets really deep really fast, that's usually a sign that it's a kettle lake that was put in there by the glaciers. We do have lakes that were post-glaciers, of course, but we have more than zero that are kettle lakes. Again, another map showing the area that we had moraines leave a bunch of debris. Lowest deposits, this is basically dust that is blown in from deserts, sometimes from places that have glaciers that build up. And it's an okay kind of soil. You could grow stuff on it, but it's very easy to weather away. Because it's made from dust, right? And so water and erosion can definitely wear it away. Permafrost, we're seeing increasing examples of permafrost melting. Very often it's kind of out in the middle of nowhere. Well, so places that people don't know about, and so we don't see it. This example in Siberia. But this is happening in Canada as well. And what happens? Well, the permafrost is just permanent frozen ground underneath. And, in Scandinavia, they would use caves as basically a freezer for the summer because it will stay that cold temperature because the ground stays frozen all year. Yeah, permafrost map, right? This is a map that is a bit evolving and changing. And when this melts, a lot of the organic material that is there lets off methane gas, and it's a greenhouse gas. And so the melting of the permafrost, or maybe you've seen these examples where so much methane is leaking out that you could light it on fire. Ice loss, I've talked about it a lot, some of the specifics, rates of loss. It's a fair amount. It's enough that actually new areas are kind of emerging that geographers like to study, because geographers like to study what happens to a new area that used to be covered in ice and all of a sudden it's not covered in ice, right? How fast do plants and animals kind of take it over? What do they do? How is it weathered through time? Areas of ice loss, Antarctica. Again, a lot of this is out of sight, out of mind. You might see it on the news, but it's not really covered that much. And it kind of depends on the political environment, how much it's covered or not. Kind of has its ups and downs. Now, of course, most of the population of the Earth live on coasts, right? So if we have sea level rise, we have lots of places that are just inches above sea level. So we do have some different islands that have become uninhabitable, where the populations have had to just move somewhere else. And very often they'll kind of like put everything on stilts for a while, but there's only so long and so much you can do if everything is on stilts and you don't have any dry land anymore. And that's it.